All right, everybody, we are in 2-1. Angles and congruence. I think I'm on the wrong page. There we are. For geometry, Tennessee Reveal. So someone messaged me saying that my pop-ups were not coming up. So let's see if we can figure out what's going on. They couldn't see me solving equations. So I'm going to try this again. Okay, so we're getting into it. A lot of different words you need to know. Ray, opposite ray, straight angle, angle, sides, vertex, all of these I'm going to go through as we go. Okay, no problem. All right, so listen, we've got a ray. So a ray is definite beginning point. We call that an end point and extends out in different directions. When you're naming this, you start with A, so you can name it AB because it's going through B, or you can name it AC because it's going also through the C. Don't use 3 letters. That is something completely different. If you have rays going in opposite directions, like one of them is going left, the other one is going right, these are called opposite rays. It makes a straight angle, which is 180 degrees, or a straight line, however you want to call it. Basically, it's the same thing. When naming an angle, you want to name it with the vertex in the middle. Now, I know they gave you the vertex definition down here, but the intersection where 2 rays, I guess, intersect, begin their endpoint, when they have the same endpoint, the common endpoint, like this A right there, that's your vertex. So we got ray AD, and then we got ray either AB or AC going to the right. So this is angle A. And anytime you name it with 3 letters, you want the vertex to be in the middle. See, A's in the middle, A's in the middle, A's in the middle, A's in the middle. So you name it different ways. DAB, like connecting the dots. DAC is correct, or the vice versa of those. BAD, CAD. But the vertex letter has to be in the middle every time. You are given 2 sides when you create an angle with rays. You've got ray AD, that's your side, and then you've got this other ray, that's your second side. So either AB or AC. All right, moving on. And again, feel free to pause this video as you want to. Going to the next page, at the top of the page, they give you interior and exterior. Don't do really too much with that in geometry. I guess it's more for the visual people. So same angle we were talking about. Now you've got point G on the interior of the angle F and H, all points on the interior. If they are on the exterior of the angle, then we call those exterior points. I, J, and K are all on the outside part of the angle. Therefore, they're in the exterior. All right, let's go down to an example. See if I can't make this a wee bit bigger. So example number 1 says, use the figure to identify the angles or parts of the angles that satisfy the given condition. And in this pretty picture, I'll use that term very loosely. This picture right here, name all the angles that have the vertex or have D as the vertex. All right, so there's your D. Well, let's see. They have EDF, EDF. We could also use EDB, which I don't think they have that one. EDB. All right, back to it. EDG going to the right. They have that one. You can also going in a downward motion. GDH is one. GDC is one. Okay, well, we don't have it. We don't have GD. Oh, we do have. There's GDC. We don't have GDH. Hey, there you go. GDH. Name the sides of angle 2. All right, well, angle 2 is right here. There's your arc, excuse me. So BA, and over here is BD. BA, BD. I need a ray. I need a ray. How do I get a ray? Let's go to geometry. No. This is like really tiny. How am I supposed to see this? BA. Does that go in? Hey. So BA, and I'll do BD. You can also do BG if you want to, but I'll do BD. And go to geometry, ray, BD. Look at me go. All right. Name a point in the interior of FDE. Where is that? Where's F? F, D, E. So they want a point on the inside of this. Well, the only one I see is A. A is on the inside. A it is. Name a point or points in the exterior of FDE. F, D, E. All of the ones that are not over here would be G, H, C. Any one of those. So you either put G, H, or C. I don't care. Pick one. Oh, okay. They say points. Fine. We'll put all three. G, H, and C. G, H, C. Oh, Lord, help me. H, C. Okay. All right, we got a check coming up. So use the figure to identify the angles or parts of the angles that satisfy the given condition. Which angle has sides DB, DB, and DC. And DC. Oh, that's angle 2, y'all. Angle 2 has DB and DC. And I wish I had a highlighter. That'd be like outstanding if I could highlight this sucker. Here, clear highlights. Well, darn. Anyway, it's angle 2. Definitely not 3. Oh, okay. I got multiple answers here. Okay. So B, D, C is a correct answer. Okay. It's vice versa. C, D, B. C, D, B is a correct answer. E, D, C. No, that's not. That's this one. That's way down here. That's angle 4. So that's not good. Definitely not 3. ADB. ADB. No, that's angle 1. ADB is angle 1. Maybe all of my answers. Yep, I guess that's it. Well, there you go. There's your check. Moving on. Okay, congruent angles. See these little arcs, little 1 slash, and this little 1 slash. Congruent means they are same measure. They are equal to each other. So these two angles are the same. You will also see angle bisector. It means that these are not only the same, but angle QTS, which was originally 120 degrees, got split into 2 equal parts. So a 120 split would be 60 and 60. All right, example number 2. Okay, I got to teach you guys how to read directions. Yada, 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 bisect. That word bisect typically means that you've got 2 equal things going on here. Like this 120 degree angle is split into 60 and 60. So if ABE has been split into 2 equal parts, these 2 things are equal to each other. DBE and ABD are equal. So I'm going to pull up another tab because this is where the program is not allowing me to actually solve anything. The firewall is blocking me. I'm going to pull up a tab for equation editor. I'm going to put 4x plus 14 equals 8x minus 32. 4x plus 13 equals 8x minus 32. 8x minus 32. Now, this is not a great way to show you guys, but it's the only way I got because the firewall is up. I'm going to subtract 4x here. I'm going to move to the other side. I'm going to subtract 4x to the other side. So what I end up with is 13 equals 8x minus 4x is 4x. And I'm bringing down my minus 32 because I haven't done anything with that. I'm going to add 32 to the 13. So I'm adding it to the other side. And what I end up with is, what's 13 plus 32? That's what, 45? 45 equals 4x. And then, of course, I got to divide by 4. So I'm going to take 45 and divide by 4. And I get 11.25 for the x. All right, so x is 11.25. Okay, so first solve for x and then find, okay, so now I got to plug back in. So I'm going to take my 11.25 and I'm going to plug that sucker back in to DBE, which of course this one's labeled DBE, so I'm going to plug it back into the 8x minus 32. So grab your calculator. Grab your calculator, everybody. I'm going to take the 8x minus 32 and I'm going to replace the x with 11.25. So I'm going to multiply times 8 and then subtract 32. So times 8 and then minus 32. And I got 58 degrees. So it looks like it's going to be 58 degrees. Okay, there you go. All right. Oh, and it had me do it here. You know what? Darn it. Had I known that, yeah, I would have just worked it out here. Oh, well. So I got you the equation editor. We'll just go from there. And here's where they plugged it in. And so that should have been 58 degrees. Oh my gosh, maybe equation editor was better than this. That's horrible looking right there. How am I supposed to plug all that junk in? That's crazy. Can you do better than that? Oh, okay. Looks like I got to check. All right, see that word bisect? Okay. I'm thinking I'm going to set them equal to each other. So JKL has been cut in half. These two are equal to each other. Yeah. So 8x minus 13 equals 6x minus 11. All right, let's go back to the equation editor. 8x minus 13. Let me clear all this out. 8x minus 13. And that's going to be set equal to the 6x minus 11. Okay, so I'm going to subtract 6x to the other side. Because the opposite of adding is to subtract. Well, 8x minus 6x is 2x. Bring down my minus 13 and bring down my negative 11. I'm going to add 13 to the other side. Oops. So now I've got 2x equals negative 11 plus 13 is a 2. And divide both sides by 2. Well, 2 divided by 2 is a 1. So x is a 1. Now they want me to plug back into JKN. JKN was this one. 8 times 1 is 8. Something up with, unless I did something wrong. Minus 6x is 2. Add 13 to get 2. 2 divided by 2 is 1. 8 times 1 is 8. Minus 30. Yeah, this problem's messed up. Whoever wrote this problem is, I'm not going to say. 8 times 1 is 8. Minus 13. The reason why it's messed up is you can't have a negative angle in high school geometry. Now you can in calculus, and there's a different whole story right there, but somebody done messed up. 8 times 1 is 8 minus 13. Oh, that's a negative 5. Yeah, somebody done messed up. I'm just going to leave that one alone. My mama always said if you can't say something nice, don't say nothing at all. So whoever wrote this section, I ain't saying nothing at all. I'm just going to move on. All right, adjacent angles. Angles that are beside each other. Linear pair. Angles that are beside each other, but they make a straight line. And vertical angles. These are opposite angles, and they are always equal to each other, you guys. This angle 1 that opens up, this angle 3 that opens down are vertical angles, and they're equal. This angle 4 that opens up to the left and 2 that opens up to the right are also vertical angles, and they're equal to each other. I love vertical angles. They're equal to solve. Okay, what is this? Example number 3. How many pairs of adjacent angles do you see in the picture? List 2 pairs. Well, these are adjacent. These are adjacent. These 2 are adjacent. And these 2 are adjacent. Yeah. Then I've had 2 pairs of vertical angles. Well, if this left angle is 138, so is the right one. And this top angle is vertical to this bottom angle. Those are verticals. How many linear pairs do you see in this? Oh, it's the same darn thing. 4. 1, 2, 3, 4. Lord. Oh, I can't move on yet. Find E. You know what? Find EBC. Okay. EBC. Well, I've already said it. If your left angle is 138, your right angle is 138. So find EBC, 138. 138. All right, so let's find ABE. ABE is this angle. 180 minus 138. Well, what is 180 minus 138? Grab your calculator. Put in 180. Subtract 138. You get 42. The answer is 42. So by the way, if this angle ABE is 42, so is this bottom angle CBD. It's also 42 because vertical angles are equal to each other. Okay, here we go. Last question is the check. All right, as planner is designing a park. He wants to place 2 pathways that intersect near the center of the park. If GED is 88, identify the truth statements. Well, I'll tell you now. If this left angle is 88, then this right angle is 88. So FHE, 88 right there. FEH. Boom. FEH, 88. Now, those are the only 2 that are 88. So this one, bad answer. So if the left is 88, the right is 88, and those are the only 2 that are 88. 180 minus 88 gives me the top angle and its opposite vertical angle. So DEF is 92. That's a good answer. And GEH, oh, no, they have it as 88. That ain't right. What is DEH? No, DEH ain't right. That's a straight angle. So that's 180. And DEG is already 88. Oh, those are only 2 answers. A and C. A and C. All right, is that it? I think that's the last one. Yes, there's the practice. Y'all are on your own. Good luck. If you have any questions, let me know. Y'all have a good one.